In this section, we're going to be talking about properties of the atmosphere. And there's essentially three properties of the atmosphere that you need to know. The first one is temperature, and the second one is air pressure. And then the last one is humidity. And we'll talk about those three really quickly here. This section is pretty easy, so there's not a whole lot that you don't already know. So temperature can be measured different ways. Fahrenheit is the scale that we're the most used to. Celsius is what the whole rest of the world is using pretty much. And then there is also Kelvin for measuring kind of extreme highs and lows. So there's different ways of measuring temperature. And then air pressure is kind of interesting when related to the atmosphere because generally, the higher you go, the less pressure there is, meaning there's just not as much, even for you, breathable air the higher you go. And this is why you get out of breath when you go higher. That's why athletes that train high up in the mountains or high up, maybe in Colorado or something like that, they come down and then they play sports down here at sea level, and there's a lot more oxygen and they can actually do a lot better. I went to one college that was way up in the mountains, and man, my ability to exercise and perform at my best went way down because I wasn't used to the lower oxygen at first. Now that changed over the time and I got used to it, but it is cool for you to, if you are an athlete, to train at higher elevations so that you come down to lower elevations and there's more oxygen available. All right. So, in general, as air pressure increases, the temperature will also increase. This is how very popular pressure cookers like the Instant Pot are working. They increase the pressure and that raises the temperature really, really rapidly. So, the opposite is also true, that as you lower the pressure and take pressure off, the temperature decreases. So these are on a relationship where one goes up, the other goes up. Okay. So here is something, an interesting phenomenon that is important for you to learn called temperature inversion. So in temperature inversion, here on the left side, I want you to look at that one first. This picture first. Generally, warmer air is closer to the ground, and if you go up higher and higher and higher, it will get cooler and cooler and cooler. And normally, hot air rises. So, as this air, warm air goes up and the pressure releases, it cools off more and more because there's less pressure the higher you go up in the atmosphere. So, this is the normal way of functioning. Okay. Now, sometimes, and I lived in a spot like this one time, you have something where you can get these things called temperature inversions. And that's where the ground can cool off really rapidly. Like if you live near a large body of water, or sometimes if the ground is very desert and doesn't hold, maybe doesn't hold the heat, or like concrete or something like that, where it's not holding the heat. Well, the concrete would, but in a space where it's not holding the heat on the ground. And usually this starts to happen at night. What happens is the ground cools off really quickly, and then there's this blanket of warm air that's like a lot less dense. Now, this cold air doesn't rise. It's got an upward arrow, but try to ignore that. I think it's just trying to indicate that they're touching right there, the warm and the cool air. But the cold air doesn't rise, it actually sinks. So it stays near the ground, and this warm air is actually up here. So holding it in, and they're not mixing. This is called a temperature inversion. The problem with this is that it really, normally with the warm air rising, all the pollutants and gross stuff that's on the ground and air kind of floats up into the air. And we at some degree it's cleaning the air for us. So all that gross stuff and pollutants is held down by the warm air. And this can include smells. The place that I lived actually had a meat packaging plant, but for like the dog food, so it was like old meat. It smelled every every day when we had inversion because all those smells, everything was just held to the ground. Um, so that was kind of a gross, interesting experience with inversion. So you can get these temperature inversions. Um, what else do you need to know? So just it increases pollution, but it happens over places where the ground just cools off really quickly, and it doesn't have time to have this normal process. And here's a layer of that where the smog is like held in by an inversion. Sometimes when I'm pulling away from Long Beach on a boat or something, you can actually see this over the city. So moving on, the last important point about atmospheres is humidity. So humidity is the amount, I want to find a nice picture for you guys to look at. We'll look at this picture. Humidity is the amount of water vapor in the air at a certain amount of time. And that obviously changes by place. And even at that place, at times of the year and day and everything, how humid it is. So saturation is when that amount of water vapor in the air is completely full and it cannot hold any more water. That is considered fully saturated. So, relative humidity is basically how much water the air can hold or is can hold. And the higher that you go, the less water can be held because there's less pressure, so there's less air to begin with. So the moisture will condense at higher levels, which is why clouds get made up higher. And so the water can't hold as much. So as that water vapor goes up higher, it will start to condense in clouds and often start to fall. The next term that you guys need to know is dew point. Dew point is how much you need to cool the air down before it will condense and make rain. So sometimes at night, there's already a lot of liquid in the air. It's already really humid. And then as it cools down, that's when the dew will kind of form all over your cars or your windows outside. And that's called the dew point. Um, then this picture is something that I wanted to show you. Basically, this is talking about the condensation level. And over time, you'll see this water starts to evaporate and will condense and basically be falling at the same rate that it's going up and evaporating. So let me show you this picture. I want to make one last important point. This place where the clouds start to form, so condensation has lifted up, and then here at this level, it finally starts to form a cloud. This is called the lifting condensation level, or LDL. So point that point where clouds start to form is the lifting condensation level. So, the three most important things that you need to know about the atmosphere and how it changes with height. The first one would be that temperature generally decreases as you go higher, but that can slightly vary. But generally, temperature will decrease as you go higher. The next important point is that pressure decreases the higher you go. And the last one is that as you go up, humidity generally will go down. Okay, so those are your important points for this section. Have a great day.